So I want to cover three more things that are mentioned in the textbook that I'm not going to emphasize in class. The first is physical ERDs. I know the textbook is differentiated between physical and logical modeling and a number of other venues as well. And I still don't think that's particularly widely used in industry. In this particular case, for physical modeling, you may want to just change entities to tables or files, change your attributes to fields, add primary keys, add foreign keys, and other system-related components. I'm not particularly big on this, and I just have not seen very many organizations that have used physical ERDs. So I guess be aware that it is a thing, but not something that I'll emphasize on the final exam in this class. They do also mention SQL Optimization. The main reason that I'm not emphasizing that in this class is that we have another class, 620, that will go through that in much more detail. The only things that I'll say about it here are that there are a couple of different kinds of optimizations you might want to do. First, you might want to normalize the data so that the data is represented logically and consistently. And there are multiple normal forms based on relational algebra. This gets into database theory rather quickly, and it's not the kind of thing that I will emphasize on the final exam. Another kind of optimization is something called denormalization. This is essentially a way to address some of the cap theory concerns by adding redundancy to the database. This can also make latency better as well, but it's probably not as efficient as using something like a non-SQL database if latency is your primary concern. And then finally, adding an index to a database. These are just data structures that increase speed of access, reducing latency for common searches. So it's a very useful thing to do, but it's not the kind of thing that you want to do early on in a project, especially when you're still in the modeling phase. This is the sort of thing that you would end up typically working out after you get into implementation and identify where your latency concerns are. Finally, estimating storage size. This is something that I am kind of interested in and may ask questions about on the final exam, but it's not the sort of thing that I think is a really critical concern in the planning phase. The main reason is that your estimates are going to be estimates, and the most important piece of this is actually something like your growth rate and latency impact, and neither one of which you're going to have a good understanding of early on in a project's lifestyle or life cycle. Now, you may have good historical data, in which case you can get better estimates for things like this based on the existing system or the legacy system or your current customer base, but it's not the sort of thing that's easy to do if you don't have a whole lot of users or you don't have any history for the project. The basic way that you would want to do this is essentially just identify what is the raw size of each of the fields in a particular table, how many overhead elements do you have, keys, joins, indexes, that sort of stuff, and how often are they going to be used. And then finally, do a cost-benefit analysis to figure out how much is it going to cost for us to just continue using something like an expanded relational database as opposed to switching to something entirely different like a NoSQL database to figure out whether or not the costs and benefits would be worth it for your organization. That said, these three elements are not things that I'm typically, meaning the physical ERDs, SQL optimization, and storage size estimates, not the kind of thing I will emphasize too heavily in the future exam.